So hey, I'm here with Anika, and we're talking about the new board that we're looking at creating for the LA Robotics Club. We wanted to make something kind of small and really low cost, and we have a prototype together right now. We're looking to mass produce it, and we wanted to get your support. What have you got right there?
Well, this is going to be it's Arduino compatible, and this is going to be the board. Of course, it's not fully assembled. We're still in the process of doing that. But then we have the FTDI and the USB over here, and those two are going to go together. If you have one of these, you can have as many boards as you want. So if you later want to use anything that doesn't have the USB, the big thing that I like about this is that it's very lightweight and it's very small. And a lot of the projects at the LA Robotics Club that we do are like quadcopters, maybe aquatic. Very small projects. We have a couple of little rover projects that we're working on, and I'd really like to get everyone in the club to where they have a smaller board like this that they can put on their project. Now we're looking at $5 for this board, and then another $5 for this, but you could order like 10 of these for $5 each, and then also if you lose your quadcopter, which we've had people do, I think we've got one or two in the Pacific Ocean right now. That way, it's got the exact same power as like a larger microcontroller.
Cool. So then it's going to be Arduino compatible, right?
Yes.
So if I could use the
It's
Arduino
open source.
IDE
Yes, exactly. You could use the IDE.
Yeah. Cool. And this could be picked up at the LA Robotics Club meetings, or it's going to be shipped anywhere in the world as well.
Yeah,
so.
we'll have to add shipping if people aren't local. The main idea of this is to have something for everyone in the club.
Yeah.
That's very affordable.
Yeah.
And yeah, I'd like people to be able to pick it up at the club. I'll have,
And I think when we were talking about the designs, we wanted to have VCC and ground on all of the analog ports, and I think there's going to be 6 total.
Yes,
as well
6,
as
so it'll be like 8
digital.
18 whole. Yeah, 6 across the end.
Cool. So then it'll be low cost, it'll be fairly lightweight,
Yeah.
so it looks like it could fit into a rocket body or one of those really lightweight helicopters as well.
The vast majority of the components will be through-hole. So if for some reason your, your chip burns out, it's going to be in a socket.
Right.
So you can just pull it out and put in a new chip
instead
of having to throw away your board. And then the other components are all going to be through-hole as well.
I think the other reason we did that was so if you wanted to add software in the field, you could just program the chip, take the chip with you, and then swap the chips out instead of bringing the whole board out. If you, like, I know a lot of some of the projects I do, I have the board physically mounted onto either a helicopter or something, and I don't want to lug the helicopter into my office. I could just pull the chip off, put a new chip on, and upgrade
and then you
the
have
software.
something that fits in your pocket.
Yeah, cool.
Yeah, and it's got all the exact same. It's going to have the same amount of inputs and but it'll be much cheaper. It'll be much smaller, and I'm hoping to make it a little more versatile than the larger boards.
Right. Okay, excellent.
Okay.